My name's Itamar. And so the problem I'm working on is fixing performance issues in data-intensive batch jobs. So long-running batch jobs, you're processing some data, you read it in, you process it. And I first encountered this in a job where I was doing some scientific computing. So we were processing large amounts of images using pandas. The job took a long time to run. It was something like 6 hours, approximately, maybe longer as you scaled up the data. And so taking that long to process the data wasn't great. And then I went and did like some calculations about our cloud computing costs, and we were going to use 70% of the company's revenue on the cloud, which wouldn't leave very much for things like my salary. So this was not good. And mostly just my code was super slow. So then I went and tried to make it faster. I tried to cut down memory usage. And this is where you hit problem number 2, which is measuring performance on these sort of programs is kind of hard. You need real data. Like if you do the tiny simulated data subset, it may not give you the performance problem. Well, it may only happen with real data. The production environment where you're running your batch process makes a lot of difference. Network latency may be different. You might have access to way more RAM or way more cores than your laptop has. So it's just different. Sometimes only certain data sets cause problems. If things are taking 6 hours to run, then your feedback loop is slow. And so I've been working on a software tool, a commercial product to solve this, which is a profiler with the goal of giving you, if you know what your performance bottlenecks are, if you're using too much memory, you can get faster results, lower your computing costs, and have less carbon emissions. And I want this to be profiling because unlike tracing, stuff like open telemetry, you can find things you didn't know that you needed to instrument. I can tell you this line of code is being slow. You need a profile that runs in production for the reasons I talked about in the previous slide to actually get realism. So you want the real performance impact, not just an approximation in your laptop, which might not be sufficiently realistic. And you want always to be always on because unlike a web application where you can sort of turn it on for 5 minutes and turn it off, by the time you notice your batch job is slow, that part of the batch job may be over. And so you have a profile that's always on. And most profilers for Python just are not designed to run in production. Here's an example of some of the profiling output. Given a lightning talk, I can't go into too much detail, but one thing to notice is that it gives you stack traces and tells you how much time is spent running, doing computation versus waiting. And so here you can see there's 2 threads and they each spend about half their time running versus waiting. And so what's happening is they're both fighting over the global interpreter lock. So each thread is spending only half its time doing computation, the rest of the time just waiting. And this is the thing also most profilers, normal profilers don't tell you. I've also created Phil, which is a free open source memory profiler. You can't use it in production, but if you go to pythonspeed.com/FIL, you can use it for offline memory profiling. Sciagraph is also on my website. I expect to start an alpha release tomorrow. So if this interests you, please get in touch.